I was watching another one of those really cheesy 1960s Godzilla movies the other day, but this one had a really cool rocket in it. Take a look. Huh. So if I build that rocket, will it fly? Let's find out. The first thing I needed was detailed measurements. So I put some still shots of the movie up on the TV, and I took detailed measurements of all the different parts of the rocket. I took that information and headed over to the Open Rocket software. I put the basics of the rocket in the software, but right away there was a pretty obvious problem. This rocket is not stable. For the diameter, it's a very short rocket. It was designed to look good on a film set, but certainly never designed to fly. Now, I could make this design stable by adding about 800 to 1,000 grams of weight up into the nose of the rocket, but I don't really want to add that much dead weight to the rocket, and to be honest, I don't actually think I could fit 800 grams of weight all the way up into the tip of the nose cone. So instead, I decided to make some design changes. I increased the length of the body tube by 85%. I increased the length of the upper transition and the nose cone by 50%, and I increased the width of the fins by 90%. This provided a stable rocket design that still has the basic idea and concept as the one that's shown in the movie. I used Tinkercad to design all the 3D printed parts, and I used Carbide Create to design the fins that would be cut out on the CNC cutting machine. It took about 32 hours to 3D print all the parts, and they came out looking really nice. The CNC machine was used to cut out the fins as well as several other internal parts such as centering rings and bulkheads. And when finished, they just needed a good sanding around the edges. The body tube and coupling pieces are made from 4-inch cardboard shipping tubing, and the pods that are on the fins are made from Estes BT55 tubing. I used a milling bit in my drill press to cut the slots for the fins, and then I used a Dremel tool with this small cutting bit to cut the slots in the pod tubes. Alright, these are all the parts I need to build this rocket. Let's take a look at what we got, starting with the 3D printed parts. I've got 4 of these little nose cones that go on the top of the fin pods, and then I've got 4 little landing feet that go on the bottom of the fin pods. And then there's the upper body transition and the nose cone. And then there's the exhaust cone that goes at the bottom of the rocket. Now, as far as cardboard parts, the main body is 4-inch cardboard shipping tube. This is the lower section for the fins and the motor, and then there's the upper section that will go on top of that, and there's a coupling ring that will join those two together. Then we have the 4 fin pods. Those are Estes BT55 tubing. And then we've got some parts that go on the inside. We've got the parachute bulkhead that also has a ring that goes above it so that it doesn't get pulled out, and then there'll be a length of paracord that gets attached to that so we can attach the parachute shock cord. And then we've got the motor bulkhead or the motor stop that the motor pushes against, and then there's 3 rings for fin assembly and motor centering. And then we've got the fins. Now these fins were very specially designed. You see we've got this little hook up here that actually hooks onto the inside of the cardboard tube. I figured this fin is going to have a little bit more stress on it than most of the ones that we normally do because we've got these pods on the outside and they're going to just add a little bit more air resistance. So that little hook on there means that in order to rip this fin out, not only would you have to detach the fin from the assembly that we're going to be putting on the inside with these rings, but it would also have to rip through the side of the cardboard tube. So that's going to be really strong. And then we've got these 2 little legs on the outside that go into the pods like that. And then lastly, we just have the two rail buttons that will be attached to allow the rocket to slide onto the launch rail. So we're ready to assemble. Now the glue we're going to be using for this is Loctite PL construction adhesive. Now this takes several hours to dry, but I really like using this product because it's a thick adhesive that doesn't run, it's extremely strong, and it expands a little bit as it dries to help fill some of those little gaps. The motor that we're going to be using for this rocket is our Super Monkey rocket motor. This is a PVC case motor filled with Flexi Fuel sugar fuel. Now I'm currently working on a Super Monkey Extended, which will be about an inch longer than this if it works out right. And this rocket has been designed not only to hold the standard Super Monkey, but it will also be able to hold the extended version if we want to launch it with a slightly more powerful motor. So let's start building. I decided to attach the pods to the fins before attaching the fins to the rocket. I think that'll make it easier to get these two parts aligned. So I made a spacer out of a 1/2-inch piece of MDF and a thin piece of 3D printed material. That's going to hold the fin at the proper height, so when the tube is attached, both parts will be properly aligned. So I'll start out by putting a little bit of adhesive on the ends of both legs of the fin, and then a little more adhesive along this surface here where the fin comes in contact with the tube. Insert the tube and place it on the spacer. I put a little weight on the fin just to keep it from moving, and then I placed a block against the tube with a little weight on that just to keep that in position while the glue hardens. I'll let that adhesive dry for a couple of hours, and then I'll just repeat that for the other 3 fins. They came out looking really nice. Now I just need a little bit more adhesive on the inside just to reinforce the bond between the fin and the tube. And then I'll install fillets between the fin and the tube. For that, I'm going to use the Liquid Nails construction adhesive. A fillet is just a filler in between the two parts, just to fill that gap in and make a nice transition between the fin and the tube. Now we're up against the trickiest part of this build, and that's attaching the fins to the body tube. Now all my fin alignment tools are designed to hold the fins at the bottom of the tube, but that's not going to work for this design because these fins are up a couple of inches from the bottom, so we'll need to do things a little bit differently. Now, when we attach these fins, they'll need to be positioned and aligned in 4 ways. First of all, we need to push the fins in so that they're fully in contact with the body tube. Second of all, we need to make sure that all 4 of the fins are at the same height. There's a little bit of play in the slot, so we'll need to make sure that they're all positioned at the same height. Thirdly, we need to be sure that the fins are not crooked in this direction. And then lastly, we need to make sure that the fins are properly aligned in this direction. But before we get to that, we need to do a little bit of prep work on the upper binding ring. This is the ring that will go in and attach to the top of all the fins. It will bind all 4 of the fins together and also bind them to the tube as well. Now this has 4 slots on it, and if we just put this in right now, it would just slide down past the fin tabs and go to the bottom of the body tube. So what I'm going to do is cut 4 small pieces of paper, glue them onto the top of the slots, and then when the glue's dry, I'll cut off the excess. That will allow this ring to sit at the top of the fin tabs. Now to help get these fins positioned and aligned, I'm going to put these little clips on the top of the fin, and then I'll put a rubber band around the fin and that clip just to help keep that clip in position, and then connect each one of the fins into the body tube. And then I've got this large rubber band that will just go around all those clips, and that will just apply a little bit of tension on each one of the fins, pulling it in towards the body tube. I'll place a bunch of heavy cans around the fin pods to hold them in position. And then I have 4 little spacers that are all cut to the same height, and I'll place those under each one of the fins to keep them all at the same height. I'll put some adhesive on the inside of the body tube as well as on the tops of the fin tabs, and then I'll place the binding ring in position. Here's a close-up of the finished installation of that ring. Now that the ring is glued in place, all I need to do is sight down each one of the fins and move the cans around until I see that the fin is perfectly centered over the slot in the alignment tool. If it's off too much to one side, I'll see more of the slot. So I'll just go around and position each one of those fins so that it's right over the alignment tool slot. Now the last thing we need to do before we let that glue harden is make sure that the fins are aligned in this direction. Now if we take a look here, we've got a little alignment mark above, and if we move the shim, below each one of the fins. So I'll just go around and make sure that all the fins are lined up with that alignment mark. If any of them are off a little bit, I can just take a little toothpick and stick it in between the cardboard tube and the fin, just to push the fin into the proper position. And then we'll let that glue harden overnight before we touch this part.
The next day.
All right, that adhesive is completely dried. So I'll go ahead and remove all these cans, and then I'll take off all the rubber bands and clips holding this together. Next, I need to install the lower fin binding ring. Now, I've already glued the pieces of paper over the slots in that like we did in the first one. But before we do that, I need to apply some adhesive to both sides of the fin tab on the inside of the tube, because after I glue this in place, I won't be able to reach my hand down in there anymore. So now is the time to finish gluing those fins to the cardboard tube. I'll glue in the lower binding ring. And then install fillets between the fins and the body tube. This is looking great. So now I can install some more of the internal parts. I've got the lower motor centering ring. So I've got a little spacer here that's going to hold that up to the proper height so we can get that glued in position. So I'll go ahead and get that installed. Next, I'll install the motor bulkhead at the top. Now I've also got a spacer for that. That'll go down inside the tube. That holds the bulkhead at the proper height, and then the coupler gets glued in on top of that. So I'll go ahead and glue that in place. Now I'll glue the nose cones onto the fin pods. And then we've got some decorative pieces that go at the bottom of the rocket. The first one is this engine cone that just goes in the bottom here like that. Now this needs to be removable because of the way that the motor gets installed here. We have a retaining system to hold the motor in place, and once that's locked in place, then this just goes in on top of that. I've designed this with a twist lock type of system, so it'll go in and you just turn it to lock it in place. So I need to glue in the 4 little pieces that this twists around. With those tabs in place, this piece just slides on like that, turns, and locks in place, and then just comes off just as easily. And now I'll glue the 4 landing feet that go into the bottom of the pods. Now I'm going to start working on the upper section of the rocket. I've got the parachute bulkhead and the retaining ring that gets glued in on top of that to keep that from getting pulled out when the parachute deploys. And I've got the short length of paracord already looped in there. I'm just going to tie a knot in the paracord just so it can't pull through the holes. And that's ready. Now I've also got a spacer here that will hold the bulkhead in the proper position in the rocket. So I'll go ahead and get that glued in place. I was about to glue the transition onto the top of the rocket body, and then I realized that there's a design flaw here. You see, the transition goes from 4-inch diameter down to 3-inch diameter. And the parachute we're going to be using is our 5-foot ripstop nylon parachute, which fits nicely into the 4-inch tube. However, it does not fit through a 3-inch tube. So if this was part of the rocket body, we would never be able to eject the parachute through that 3-inch diameter. So that means this needs to be part of the nose cone that gets ejected off of the rocket. Now, rather than make a whole new piece, I just made this little adapter that fits onto here and gives us that nice sleeve that fits into the rocket body. And then we'll take the original nose cone piece and glue that onto the top. So this entire piece will be our new nose cone. So I'll go ahead and glue those 3 pieces together. Now I'm going to install the upper rail button that goes right here on the body tube, and then I'm going to drill 8 small vent holes in the tube for the venting needed for the flight computer. I've got all those locations marked, so I'll take this out to the shop and drill those holes. Now I just need to glue the top section of the rocket onto the bottom section of the rocket. And the final part is the lower rail button. This rocket build has come out absolutely fantastic. I am super happy with the design. Now, the build is finished and we could launch this rocket just as it is, but personally, I don't think a rocket is complete until it has a really nice paint job. So I'm going to try and duplicate the paint job shown on the rocket in the movie. But before we get to that, some of you might be wondering, where's the electronics bay? Where's the flight computer in this rocket? That's a great question because we never built an electronics bay into the rocket. Well, a couple of years ago, we came up with this system where the flight computer, the battery, and the ejection charge are all mounted to this base plate, and that gets screwed into the bottom of the nose cone. We've used that on several different rocket designs, and it works great. So, time for painting.
Verification check to proceed with ascent sequence. Platform systems propulsion. Go. Guidance. Go.
Tether.
Go.
Environmental.
Go. Maglev track. Go. Payload integrity. Go. Skyhook systems. Anchors. Go. ECS shielding. Go. Threshold monitor. Go.
Capture systems.
Go.
Umbilicals.
Go. Range orbitals and clear to proceed. Go.
I'm almost into the mainframe. I'm in.
Hey, you don't have to hack the system to get yourself a Rotary Rocketry t-shirt. Click the link in the description to access our shop.
Hey, check this out.
Available in a wide range of colors with a variety of graphics. Get yours today.
All right, it's a beautiful day for a launch. So regardless of how today's launch goes, I had a fantastic time building this rocket. It had some really unique challenges that we had to work through, but in the end, it came out absolutely fantastic. And I think this is probably the best looking build I've ever done. But it wasn't meant to be a decoration, it's meant to be a rocket. So let's go and launch it. In 3, 2, 1. I see it. Freckling over.
It's turning. Pop. There we go.
Well, we got to 846 feet, which is a pretty good launch for this size rocket and this motor. Now, unfortunately, my error. Somehow when I hooked up all the cords for the parachute, I missed 2 of them. So only 6 out of the 8 shroud lines were connected, which allowed the parachute to kind of flip up on one side and really just not deploy properly. The rocket came down just a little too fast. Now, we took on a little bit of damage because the first impact point was one of the bottom of the fin pods. Now, realistically though, I think we probably would have taken on damage to one of the fin pods even if the parachute had deployed properly. They're just really thin Estes tubing, so the fact that the rocket comes down and smacks onto one of these pods first, we were probably always going to damage one. Now, this is fixable actually, and I really like this rocket enough that I think I actually will fix this. Now, whether we launch it or not, that's a whole other story, but it is a fixable problem. So, hey, thanks for watching. Give us a like if you like what we're doing. Don't forget to hit that subscribe button. We've got a lot more content coming up. We'll see you next time.